such that when L, gets bigger than or equal to or goes beyond this n epsilon, this is happening. Okay. And if I take its complement, what would be the measure of this?
0 greater than epsilon.
The measure of this set must be 0. Okay, this is what the set theoretic version of saying the same thing is. Okay. Is it making sense? Now let's write this complement explicitly. Okay. Let's write this complement explicitly. Okay. So what will be complement of it? So the complement of it is going to be union k equal to 1 to infinity of intersection n epsilon from 1 to infinity
Union
of union
L bigger than
or equal to
n epsilon.
and epsilon you get x such that
If of
f(L) of x minus
if of x
f of x is
bigger than
bigger than 1 over 2. Okay. And this has a measure 0. Okay. And now since mu is a measure, I can write this for the first union. So the measure of the union of these three H's is equal to k equal to 0 to infinity of the measure of the intersection of n epsilon bigger than or equal to 1 to infinity union of L bigger than or equal to n epsilon of x, that was the same quantity, equal to 0. Agree?
less than equal I am what is joint short measure less than equal to this set distance.
There must be, okay. So you're saying less than or equal? No. Should it be the case? So if you see, so it's like, it's not subadditivity. So mu is a measure. So the mu of the union would be, the measure of the sum of the measures of the sets. Okay. Okay. The only thing that you can think of is that are we in the assumptions actually? Are we in the business? Okay. Okay. So you must be in the business. So you have this. Now this sum is a number which is equal to 0. What you can say about these guys?
Sum is of 0 from that.
So they all must be 0. There is no other choice actually, because I know that the measure is positive actually, not negative. So this implies that measure of intersection of n epsilon bigger than or equal to 1 of the union L bigger than or equal to n epsilon. You must be saying that sometimes I'm writing in this way, sometimes I'm writing the other way, but we can okay. X such that f(L) of x minus f of x is bigger than 1 over k equal to 0. Okay? This is true for all k. By the way, give these objects a name and say, call it an or an epsilon, doesn't matter. Okay? Call it an epsilon. An epsilon is some integer actually. Okay. Then what? What do you can say that, so will that be, sorry, not the union. Not the union, but just this set actually. Okay. No, it's whole union, yes. Okay. So call it maybe A and epsilon. Now, what we can say about this set, is it increasing or decreasing? So in other words, if I have, for example, an and an plus 1, which is bigger? Should this be decreasing? Why? Because so for an, I mean that L is starting from n and going onward. And for an plus 1, n is starting from n plus 1 and going onward. Okay. So this sequence is decreasing. Okay? Decreasing. Are you getting the point? So now, if I take the limit, okay, so if I take limit on both sides, limit n goes to infinity or n epsilon goes to infinity, okay, on both sides, okay, what you're going to get? So by the continuity property, so if I have a decreasing sequence, so this would be equal to the measure of the union of L bigger than or equal to n epsilon, okay, x such that Fl of x minus f of x bigger than 1 over k, okay, 1 over k equal to 0. Okay? Okay? So this is equal to 0. In general, this symbol doesn't matter actually. If I wish I can put mana. But we need to see the connection to this things. So you have this. Now once we have this, what does it mean? Okay. So this is the kind of a convergence circle. So in other words, for any given epsilon, I can make it smaller than that epsilon. Okay. So, if this is true, for given epsilon and k, okay, I can find what do you call an n epsilon k, okay, depending on both, such that the measure of this union when L goes beyond this epsilon k, x such that Fl of x minus f of x bigger than 1 over k, I can control it by my choice of epsilon. I'm saying that, okay, now take that epsilon as epsilon over 2 to the k actually. So I had an epsilon previously, so using that epsilon, I have created an epsilon for this limit. That epsilon is epsilon over 2. Okay? So I got it. now consider the union of all such sets. So for every k from 1 to infinity, okay, for every k from 1 to infinity, so consider this, it's okay. So it's like a k from 1 to infinity. So k could be anything from 1 to infinity. I can have an epsilon, so L and epsilon bigger than or equal to k, such that x f L of x minus f of x bigger than 1 over k, okay? Call this guy as your set E epsilon. That's something that you are looking for actually, okay? What would be the measure of this set? I know the measure of this set should be, okay, so this is my E epsilon. The measure of this set should be less than my choice of epsilon, okay? And on its complement I must have uniform convergence. So what would be this? So the measure of this would be less than or equal to, okay, k equal to 1 to infinity of measure of the union L bigger than or equal to n epsilon k x such that fL of x minus f of x, okay, is bigger than 1 over k, okay? Just subadditivity property. So this means that this is less than or equal to sum k equal to 1 to infinity epsilon by 2k, okay? But this is precisely epsilon. Precisely epsilon. So the final thing that we needed to show that if I consider the complement of this set, on the complement of this set I must have a uniform convergence. Okay. I know it's a bit dry kind of this, but okay, so you have to learn it actually, but at least now you can see it more precisely than. See that E epsilon complement. So this will be a set intersection k equal to 1 to infinity L bigger than or equal to n epsilon k x such that fL of x minus f of x less than or equal to 1 over k. Okay? So the claim is Fn converges to F uniformly on this set E epsilon complement. Okay? What would be meaning of convergence of uniform convergence? So the meaning of uniform convergence would be that for a given epsilon, okay, I can make the difference supremum of their pointwise differences less than or equal to that given epsilon. Supremum norm जो है, okay? Uniform convergence in L infinity norm. L infinity. So I want to say that L infinity norm can be controlled by this. Okay? Okay, let's not use epsilon because we already have used epsilon. So let's use delta. So fix a delta. Fix a delta. If I fix a delta, I can find a natural number such that 1 over k is less than or equal to delta. Okay? Alright? I can find such a. Now I'm saying that take a point t from this E epsilon complement. Okay? Take t from this point epsilon complement. So this implies that t belongs to intersection a equal to 1 to infinity and intersection L bigger than or equal to n epsilon k. Okay? So this means, whatever. This means that t belongs to intersection of L bigger than or equal to n epsilon k for all k. Okay? And this means that t belongs to this set
in particular fl of t
x such that fl of x minus f of x less than or equal to 1 over k. Okay, you have to be very careful. Which case, you have to be careful. So in other words, I can choose another number. I can choose an m here. And I can say that 1 over m is less than or equal to m. So if t is, it's like this is true for all k's, then it would be true for in particular m actually as well. Okay? So you have to be careful. So I'm using a k everywhere. So you have to be careful. Okay, so I can put a m here. Would be okay. Okay. Now if this is the case, think about it. What does it mean? It means that fl of t minus f of t is less than or equal to 1 over k and it's delta. Are you getting the point? And this is true for any t here actually. So if this is the case, then just take the supreme.
over t.
For the t in E epsilon, E epsilon complement, yes, and fl of t minus f of t is less than or equal to delta. It's completely true. Okay. So, are we happy with this actually? Okay, it's a bit long, longer, but it all makes sense if you put them together actually. Okay, it's not something which is. So I hope this is convincing now. Good. Okay. So what we can do now, we can do a break. ठीक है, break कर देते हैं. कितना time हुआ?